Hello, I'm Dr. Steve Warner, and today I'm going to talk about geometric series. First, recall that a geometric sequence is a sequence of numbers such that the quotient r between consecutive terms is constant. And this number r is called the common ratio of the geometric sequence. So, for example, in this sequence, 1, 2, 4, 8, 16, 32, and so on, the common ratio is 2 divided by 1, which is 2. A geometric series is the sum of the terms of a geometric sequence. Let's look at an example. The third term of a geometric sequence is 4, and the common ratio is 2. What is the sum of the first 5 terms of this sequence? Okay, so if the third term is 4 and the common ratio is 2, then the second term we get by dividing 4 by 2 to get 2. And 2 divided by 2 is 1. Now we want the sum of the first 5 terms of this sequence. So after 4 we could get the next term by multiplying by 2 to get 8. Multiply by 2 again to get 16. And now we're just going to add these numbers up. You can do this in your calculator to get 31 is the sum of the first 5 terms of this sequence. It turns out that computing an infinite geometric series is easier than computing a finite geometric series. So let's look at the infinite geometric series first. The sum g of an infinite geometric series with first term little g and common ratio r, with r between -1 and 1, is given by this simple formula. Capital G is equal to little g over 1 minus little r. Note that little r, the common ratio, has to be between -1 and 1. If it is not, then this infinite geometric series has no sum. Okay, let's look at an example. What is the sum of an infinite geometric series with common ratio 9/10 whose first term is 10? Okay, so we're given that the common ratio r is 9/10, and we're given that the first term g is 10. So it follows that the sum of the infinite geometric series is 10 over 1 minus 9/10. You can put that right into your calculator to get that the answer is 100. Let's look at another example. If the sum of a given infinite geometric series is 160 and the common ratio is 1/4, what is the third term of this series? In this problem, we're given that capital G is 160 and little r is 1/4. We can use this information to find little g first. So plugging into the formula, we have 160 is equal to little g over 1 minus 1/4, which is little g over 3/4. So multiplying by 3/4, we have little g is 160 times 3/4, and that comes out to 120. So the first term of the sequence is 120, and the common ratio is 1/4. So let me finish it up over here. So the first term is 120. The second term we get by taking 1/4 of 120, which is 30. And finally, the third term, we take 1/4 of 30 to get 7.5. The answer is 7.5. Okay, now let's look at finite geometric series. The sum capital G sub n of a geometric sequence with first term little g and common ratio little r is capital G sub n is little g 1 minus r to the n over 1 minus r. notice that this formula is a little bit more complicated than the infinite geometric series formula. Let's do an example. Add up the first 5 terms of the following sequence. Okay, so of course we could do this just by adding up the 5 terms by hand, as we've seen, but just to get a little practice using the finite geometric series formula, let's do it using the formula. So we want to add up these 5 terms. N here is the number of terms we're adding, which is 5. G is the first term, and R is the common ratio, which is 2. You can get that by dividing 2 over 1, or 4 divided by 2, or 8 divided by 4, and so on. Now we're just going to plug these numbers into the finite geometric series formula to get, well, G is 1 times 1 minus R is 2 to the N, which is 5, over 1 minus common ratio, which is 2. If we just plug this into our calculator, we will get an answer of 31. Let's do one more example. Compute the sum of the first 8 terms of the following sequence. 1, negative a half, 1/4, negative an eighth, and so on. Notice that the sequence given here is also geometric. We're going to be adding up the first 8 terms, so n is 8. G is the first term of the sequence, which is 1. We can get the common ratio R by dividing any term of the sequence by the previous term. For example, we could divide negative 1/2 by 1 to get negative 1/2. And finally, we get capital G sub 8 just by plugging these numbers into the formula. Little g is 1, 1 minus negative 1/2 to the n, which is 8, over 1 minus negative 1/2. Once again, we can plug this right into our calculator. If you're using a TI-84, you could then press Math, Enter, Enter to change it back into a fraction, and you will get 85 over 128.